So today we are going to learn about payload. Please do some revision on previous slide. What is the definition of payload, since I will not repeat the meaning of payload in today's class. Okay, we start deriving payload requirement by returning to the mission statement defined earlier. Mission subject should be clear at the first place, that indicated by the objective, users, and operation concept. We define subject of the mission to be a natural or manufactured object of phenomena that the payload will sense or interact with. We characterize the subject by such things as its colors, size, shape, temperature, chemical properties, or frequency. As shown here, this satellite called FireSat, and the mission for the satellite is to locate the forest fire. Thus, the subject for the satellite is fire. The satellite will not just locate any fire, but predefined fires such as how big or how hot, which area, and others important characteristics. What you can see from this image, this is hurricane. This image taken by Ghost satellite. Ghost satellite consists of camera acting as sensors to take image of weather. Each tuned to particular characteristic differ by electromagnetic spectrum. That's why you can see different spectrum represented by the colors of blue, green, yellow, orange, and red. We will explore how sensors remotely detect this phenomena in details through the class. So payload is categorized into three parts, which are scientific, application, and technology demonstration. Each category defined by payload utilization and characteristic. So today I will focus on remote sensing satellite, since this type of satellite is main contribution to the satellite technology development in this world. Okay, as you listen to this video and see my face in this video, your eyes and ears start to act as sensors to help you to perceive your surroundings. Your eyes will see all the colors and your ears detect any tiny disturbance in the pressure of air around you. Payload are the eyes and ears of a spacecraft. Looking and listening from space involve sensing portion of electromagnetic spectrum. All the missions, such as communication, navigation, weather, and remote sensing, rely on the electromagnetic wave spectrum to collect data and interact with other elements of the mission. So remote sensing is a broad category of mission designed to detect and monitor subjects on Earth or other planets. Remote sensing mission monitor the global environment, observe the water, spy on enemy, search for natural resources, assess agricultural yield, observe the universe, and if detected the forest fire. In addition, remote sensing is utilized for simultaneously observing key element of an interactive Earth system, monitoring cloud, atmospheric temperature, rainfall, wind speed and direction, as well as monitoring ocean surface and temperature and current, tracking anthropogenic and natural change to the environment and climate. As you can see from the picture, this is a tsunami and earthquake damage during the event of in Tohoku on 2011. Remote sensing satellite also viewing remote or difficult to access terrain and providing synaptic view of large portion of Earth's surface without being hindered by political bound area. So actually in this picture show the detaining camp in North Korea. Also allowing repetitive coverage over comparable viewing condition. This can help us to monitor deforestation as you can see in the pictures. Identifying unique surface features. So this satellite image actually reveal strange circular clearing structures in Bendigo Forest in Myanmar. And it's actually the bulk storage of ammunition, explosive and chemical. Also, remote sensing satellite can perform terrain analysis and measuring moisture level in soil and plant, then help us to actually to locate the water source under the ground. So the quality of remote sensing data consists of spatial, spectral, radiometric, and temporal resolution. As the to design a sensor for the remote sensing, we need to consider a few design characteristics, which are the type of sensor, where some sensor measure radiated and reflected light passively, others transmit laser or microwave and measure the reflection. While the spectral resolution is the wavelength of the different frequency band recorded. Usually this is related to the number of frequency band recorded by the platform. And typical image are captured in panchromatic, multispectral and hyperspectral image that will be explained later. And current Landsat collection is that of 7 band, including several in the infrared spectrum, ranging from the spectral resolution of 0.7 to 2.1 micrometer. Where radiometric resolution is the number of different intensity of radiation the sensor is able to distinguish. Typically, this range from 8 to 14 bits, corresponding to 256 level of the grayscale and up to 60,384 intensity or shades of color in each band. It also depends on the instrument noise. While also the calibration we can define as is either sensor can be more or less highly calibrated with respect to how closely their output signal correspond to the actual physical property being measured. While spatial resolution is the size of pixel that recorded in raster image. Typically, pixel can correspond to square area ranging in length from 1 to 1000 meter. While temporal resolution is the frequency of flyover by the satellite or plane and is only relevant in time series studies or those requiring an average of mosaic image as in deforesting monitoring. This was first used by intelligence community where repeated coverage revealed change in infrastructure, the deployment of units or the modification of equipment. Cloud cover over a given area or object make it necessary to repeat the collection of said location.